Welcome to Cisco IOS Fundamentals. In this lesson, we'll take a brand new Cisco device and configure it from scratch. You'll learn how to reach the command line, move between the command modes, secure the device, bring an interface to life, and save your work so it survives a reboot. There's no mouse here, everything is tight. Let's begin. So, what is Cisco IOS? IOS, the Internetwork Operating System, is the software that runs on most Cisco routers and switches. You interact with it through a text-based command line interface. You type a command, and the device responds. Here's the key idea. Every configuration task follows the very same rhythm. You connect to the device, move into the correct mode, type your commands, and then verify and save. Learn that rhythm once, and every Cisco device feels familiar. Before you can type anything, you need a way in, and there are two. The first is the console connection. That's a physical cable from your PC to the device's blue console port. It works even when the device has no network configuration at all. So this is how you do the very first setup. The second is a remote connection across the network, Telnet or SSH. Telnet sends everything in clear text, so always prefer SSH, which is encrypted. In short, console for first-time setup, SSH for day-to-day remote management. To use that console cable, you'll need a terminal program on your PC. On Windows, that's something like PuTTY, TerraTerm, or Secure CRT. On Linux or Mac OS, you can use the screen command. Whichever you choose, set the serial line to 9600 baud, 8 data bits, no parity, and 1 stop bit, often written as 9600, 8, N1. One handy tip: if a long output pauses with the word more at the bottom, press space for the next page, or enter for just the next line. Now, the command line interface is organized into modes, and this is the heart of iOS. Each mode lets you run a different set of commands, and the prompt changes so you always know where you are. You start in user exec mode. The prompt ends in a greater than sign. This is a look-only mode. You can't change the configuration. Type enable to move up into privileged exec mode. The prompt ends in a hash. From here you can view everything and save. Then type configure terminal to enter global configuration mode, where you change device-wide settings. And from there you drop into sub-configuration modes for one specific thing, like a single interface. Green commands take you deeper, the red ones step you back up. Let's watch that in action. From the user exec prompt, we type enable to reach privileged exec, then configure terminal to enter global config, then interface G0/0 to move into a specific interface. Now, two ways back out. The exit command steps you back just one level from the interface back to global config, but the end command, or Control-Z, jumps you straight back to privileged exec from anywhere in configuration mode. Exit steps back one level and takes you all the way out. The command line has built-in help and shortcuts that make you much faster. First, the question mark. Type it on its own to list every command available where you are, or type it after a word, like show, space, question mark, to see what can follow. Second, the tab key auto-completes a command you started typing. Third, you can abbreviate. Just type enough letters to be unique. So conf, space, T is the same as configure terminal. And finally, the up and down arrow keys scroll back through commands you've already entered, so you never have to retype them. Let's start configuring. From global config, the hostname command gives the device a meaningful name. Here, R1, and notice the prompt updates the instant you press enter. Next, a login banner. The banner MOTD command sets a message shown before anyone logs in, commonly an authorized use warning. You pick a delimiting character, here the hash symbol, to mark where your message starts and ends, so choose one that doesn't appear in the text itself. A brand new device has no passwords at all, so at a minimum you protect privileged exec and every access line. For privileged mode, use enable secret. It stores the password as a strong hash. Avoid the older enable password, which is weak. Then protect the console line. Enter line console 0, set a password, and add the login command so the password is actually enforced. Finally, service password encryption scrambles the plain text line passwords in the config file. Be aware though, that's weak type 7 encryption. It hides passwords from a casual glance, but is easily reversed. It's a good habit, not real security. The enable secret hash is the strong one. For remote access, always prefer SSH over Telnet. SSH needs 4 things: a host name, a domain name, a user account, and crypto keys. So we set a domain name, create a local username and secret, and generate our SI keys with a 2048-bit modulus. We force version 2. Then, on the virtual terminal lines, BTY 0 through 4, we say login local, which authenticates against that username, and transport input SSH, which refuses plain telnet entirely. Now only encrypted SSH sessions are allowed in. Interfaces are switched off by default, administratively down, so bringing one up takes three things. Enter the interface, here Gigabit Ethernet 0/0. Give it an optional description, so you remember what it connects to. Assign an IP address and subnet mask. And then, the crucial step, no shutdown, which actually turns the interface on. Please remember this, forgetting no shutdown is the single most common beginner mistake. If a link won't come up, that's the very first thing to check. Switches are a little different. On a layer 2 switch, the physical ports don't take IP addresses. Instead, you give the whole switch a single management address on a VLAN interface, called an SVI. So you enter interface VLAN1, assign the address, and turn it on with no shutdown. Then, because the switch needs to reach other networks for management, you set an IP default gateway pointing at your router. Now the switch is manageable across the network. Here's the concept beginner's trip on most. The device holds two configuration files. The running config lives in RAM. Every command you type takes effect there immediately, but RAM is wiped on reboot. The startup config lives in NVRAM, and that's the copy loaded when the device boots. So the running config is live but temporary. The startup config is saved and permanent. To make your changes survive a reboot, you copy the running config to the startup config. The short forms are WR, or write memory. If your configuration worked before a reboot but vanished after, it was never saved. Once you've configured something, you verify it, and you do this from privileged exec. The command you'll reach for constantly is show IP interface brief. It gives you a one-line status for every interface. Read the last two columns like this. Up and up means healthy. Administratively down means you forgot no shutdown. And down usually points to a cabling problem or something wrong at the far end. A few others you'll use all the time. Show version for the iOS and model. Show IP route for the routing table. Show running config to see your live settings. And ping to test whether you can actually reach another device. When something doesn't work, walk this checklist top to bottom. 1. Where am I? Check the prompt. Configuration commands only work inside a config mode. 2. Is the interface on? Run show IP interface brief and look for a missing no shutdown. 3. Are the address and mask right? And that's the fundamentals. Remember the rhythm that ties it all together. Connect, choose your mode, type your commands, then verify and save. You now know how to reach a device, move through the command modes, secure it, address an interface, and save your work. The best way to make this stick is to practice, so open a lab, type these commands yourself, and build the muscle memory. Thanks for watching, and good luck!